Let's look at question 4 from January 2007. It says, given that x equals this function involving t and y equals this function involving x, find expressions for dx dt and dy dx. Okay, so that's a simple differentiation. So let's start with part I. So let's do dx dt first. So if x equals 4t plus 9 to the power of a half, then what can we say? Well, let's differentiate. So we're differentiating x with respect to t, so we get dx dt. This is a simple chain rule. So we get a half. This half is the power, so we times by half, and we reduce by the power by 1, so we're going to get minus half. But we also have to differentiate inside the bracket. So when we differentiate inside the bracket, we get this 4, so it's times by 4. The bracket stays unchanged, and we reduce the power by 1. So I'm going to write that as 2 4t plus 9 to the power of minus a half. Great. Now let's look at the other equation. So we've got y, and we've got it involving x this time. So it's 6e to the half x, and that is plus 1, I think. Plus 1. Let me just... I hope it's a plus 1. Okay, so we can differentiate to get dy dt. Sorry, dy dx this time, because we're differentiating with respect to x. Okay, chain rule again. So we have to differentiate this this indice here, this indice of e, and that would just give us a half. So that would be 6 over 2, which is 3e, and then this stays unchanged because e is unchanged under differentiation. So that's a half x plus 1. There, that's it. That's part I done. Now, I think that was the easy bit. So we can look at the next bit now, part 2. Let's make all of this a little bit smaller so we have more room. Hey, great. Part 2. So we want dy dt. Okay. And using the chain rule, we know that dy dt, well, that's dy dx times by dx dt. Okay. And from part 1, we know dx dt and we know dy dx. So we can just use our expressions for dy dx and dx dt now. So that would just be dy dx is 3 times e to the half x plus 1. Okay, and that's going to be all multiplied by 2 times 4t plus 9 to the power of minus a half. Okay, as you'll notice, we have expressions involve. We have our equation involves x and t's, but we just want when t equals 4. So to replace this x when t equals 4, we can either substitute t into this equation and then use t equals 4, or what I'm going to do is just find the value for x. So up here I'm going to say when t equals 4, x equals 4 times 4 is 16 plus 9 to the power of half. So x just equals 16 plus 9 is 25, square root that is 5. Okay, So now, instead of having to write another line with this substituted value of x and replace it by this expression, I can just say, well, x is just going to be 5 instead. So I've got a 3 times e to the 5 over 2 plus 1 times by 2. And we've already worked this out to be 1 over the square root of 25, so I'm going to say that's 25 to the power of minus a half. Okay, I'll rewrite this a bit neater. So we know that's 1 over 5 because it's 1 over the square root of 25. So it's going to be 6 over 5 times e, 5 over 2 plus 1. So it's going to be to the power of 7 over 2. And it wants our answer to 3 significant figures, so we'll plug that into the calculator. If we do the exponential of 7 over 2 and times it by 6 over 5, it gives us 39.723 significant figures. Question solved.